Good morning, everyone. We are back in 2025, and we are at episode number 66 for Infrastructure Matters. I am here with my buds, Keith Townsend and Dion Hinchcliffe. Welcome to the new year. And usually this week is kind of quiet, but it seems like some people decided to throw some things up in the wall, and not to mention, kind of call out to our friends in California that are dealing with what they're dealing with, which is very, very tragic. But we're going to kind of pivot over here to the technology side of the house and give you guys a break from watching out what's going on with the fires, et cetera. So with that, anybody get some skiing in or any fun stuff over the holidays?
Just family.
Just family.
Yeah, I didn't get any skiing. I did bring in the new year in camping. We went, we glamped a little bit. So that's not a bad way to bring in the new year.
Back in Tennessee?
Back in good old Cornwall, Tennessee.
Well, I can't say
I work on my accent.
I can't say I glamped. I did though. Did camp and tent camp and et cetera. Biked and hiked in Death Valley. If you haven't been there, it's a fabulous place to go, especially at Christmas time when weather is good, very, very good. So we're going to go into this week, big show in Vegas. Right off the new year is CES, Consumer Electronics Show. And usually this is not part of the data center infrastructure kind of guys, but nowadays it is because so much of what we deliver as services, et cetera, is through these kind of devices, et cetera. So it's now kind of all blending in. And Dion's got a whole lot to talk about, especially with how Nvidia stole the show there again.
That's right. Well, while none of us were there, we all we did have folks who were there, including our CEO Daniel Newman, who met I believe with Jensen. It was amazing show. He had a whole raft of announcements. Some of them were consumer and not really related to this show, but unusually for CES, there were some absolutely very, very much enterprise relevant announcements. The first significant one was Project Digits. It's a personal AI supercomputer that has 1,000 times the power of a regular laptop. And it's powered by the new Grace Hopper chip. And it's going to you're going to see it in data centers. There was already people stacking them up as high as they could go, high they could get them before they started to melt. The compute density of this thing, and it's not really rack mountable, but it's the fastest way to get a big model running anywhere you want it. Anywhere you want to put it, almost the biggest model you can think of. It'll run, and it's about the size of the new Apple Mac Mini. So it's very small, intense compute density. You'll see it really helping development shops and people actually operationally run some AI. It's and the price point it's $3,000, so it's for 1,000 times more power than you get on a regular laptop. So that was pretty cool, but that was not super enterprisey. Although you will see it absolutely in data centers and in businesses around the world, in my opinion. But Jensen came out with a full-size wafer showing that the GB200, the data center superchip that has 72 Blackwell GPUs on it, really exists. It's in production. He was walking around on stage with this single wafer that have 72 interconnected Blackwell GPUs that will form the basis of their massive compute. If you want to go all NVIDIA and get the biggest configuration that they have, you get stacks of this giant wafer with 72 Blackwell. So I see
wafer that's like this big or whatever it is. You're saying there's 72.
Yeah, it's big. It's like 3 feet across. The biggest wafer I've ever seen. And on it is his 72 connected Blackwells. They were made that way on the wafer interconnect.
So they're going to put this in one computer then?
Yes.
Like a mainframe?
AI mainframe. I think IBM has,
mainframe.
Yeah, IBM has something to say about AI mainframes. So, to help give some perspective here, the Digix is one Blackwell chip, basically. And that one Blackwell chip has a petaflop of compute capability up to FP4 with the FP4 standard. that enables you. So what kind of real work? That means that it can comfortably handle a 200 million parameter model, a Intel CPU type deal, goes up to about 200 billion parameter model. A Intel CPU will handle about a 75 billion parameter model. So this GB200, 72 times that raw compute performance. So the networking, the memory, everything that needs to be done to kind of to scale that out on a wafer, that's some pretty good computer science.
So way back when, if we're going to go talk about the mainframe again, of course, I will. Some analysts made this huge prediction of how many mainframes would be sold. I think it was something less than 20, maybe it's 15 or something. Who the heck is going to buy this? And I'm not going to say they're only going to sell 15 of them, but so this will be used for the languages, the large language.
Yeah, this is all still just training. So there's a question. We'll get to our predictions over the next few weeks, but I do have a prediction around kind of where AI is going in the enterprise. Enterprise teams are not going to do massive training. They'll do retraining. This is for the hyperscalers, the Facebook, the Metas of the world, the all these companies, Grok, so Xi.
And Microsoft has already announced they have Blackwell in the data center, and you can get special instances. You can specially select that. And this chip is intended for those massive installations. Microsoft just this week announced at $80 billion in CapEx they're going to invest this year in 2025 in their data centers. And of course, a lot of that spend will be exactly on this particular chip.
So it does bring up questions around that we've talked about over the past 2024 around heating, cooling. So power, cooling, and how do you keep these things cool? That is going to be one of the biggest problems. And of course, how are you going to power them? We don't have enough power now. It's going to take, 4 to 5 years to bring on new nuclear reactors. Companies are buying, like Microsoft, are buying coal reactors and putting their data centers next to these coal reactors and taking up all the power from those reactors. It's fascinating arms race around AI.
Wow. But I mean, just as kind of like I'll need to go online and take a look at it and kind of stuff because I missed it kind of this week. And like, I want to see this chip. So you can't even call it a chip. Can you really call that thing a chip if it's like...
Yeah, it's up to 3 feet wide, a chip.
It's a wafer. It's a big, huge, massive wafer. Okay, yes. What else?
And then finally, NVIDIA announced Cosmos. It's their new AI-friendly world model. What a lot of these large language models, they don't really have a good model of the world. They can make a lot of inferences that are trained up on a lot of incidental information about how the world works, but there's consequently a real need for world models, and it's supposed to be the most enterprise-ready, capable way so you can build true AI-powered digital twins that understand all the physics and all the geometries and everything all about the world. They had some pretty cool demonstrations of AIs wandering around inside Cosmos, interacting with that world as if they were in the real world. It was pretty cool. I don't see that. We'll see that in a lot of simulation, R&D, manufacturing, healthcare, things like that.
And when we get to those world models, I'm assuming that we're going to need these wafers.
Yes. Yeah, all they consume massive amounts of power.
Oh, yes.
Yeah, it's leading credence that maybe we are in a simulation because we're building equipment that can run simulations. So it is hilarious. This is amazing time to be in technology.
It really is.
Well, on the flip side of all this technology that we're building and the things that NVIDIA is doing, there are some new, you're calling them AI export rules that are potentially coming out or seeing pretty strong coming out from the Biden administration, even before we pass over the baton to the next administration. So, Dion, you want to kind of walk through what's going on? And I understand that there is a massive amount of conversation on this because it's giving some huge angst to companies.
It really is. So the Biden administration has proposed something called the Export Control Framework for Artificial Intelligence Diffusion. And the intent is ostensibly a good one, which is to prevent very powerful AI to getting in the hands of our enemies and being used against us. However, companies like Oracle have come out very publicly against it, saying, I quote, "It is one of the most destructive rules to ever hit the U.S. technology industry." And they warned a few weeks ago, but now it looks like it is gone through the interim final rule stage. It is not public. I cannot get access to this because of how it's supposed to be enforced is highly secret. And so it's one to watch. The Semiconductor Industry Association didn't come out swinging so hard as Oracle, but is very much against it. And the prediction is that it would reduce GPU sales in the United States by up to 80%. And I think some of that is debatable. The thing is, it's just because it's hard to tell. It's hard to understand what is in it and how it works. It's hard to judge it. But it's basically what the government did with cryptography way back in the day, so that our enemies couldn't keep their secrets from us. And this is something similar. It's like just keeping very powerful AI out of the hands of our enemies. And so it's unclear what will happen if it will make it to actual official enforcement before the new administration comes in, who may very well get rid of it after that. But anyway, it was very much the topic of discussion this week in semiconductor and in AI circles. Is kind of it's on the fast track and came out of nowhere. I mean, we haven't been tracking this, and this is kind of what we do. So it's very interesting to see what will happen. It's something that certainly our infrastructure friends in the industry will have to watch very closely and try to influence to make sure it does not overreach in it.
Is this specifically on GPUs, or is it on the large language models, or is it what does it cover?
So it's targeted at high risk uses, and it restricts users of very high volume users of GPUs. And so I'm still going through everything that it's trying to control the quantities of GPUs that come out of the United States. And it's a little bit less on the models, because what they're really trying to do is control the ability to even run the models.
Yeah, so this has been highly debated for quite some time, right? There's already GPU controls on who we can export GPUs out of. And China came out with I forget the name of the model, but that hit the news last week. What was a model that works 4 times faster than, I think it was Llama, or the model that mimics. So I think the cat is already out of the bag with some of this. It's a complex question because there's this debate on what controls Congress and the government wants to pass, because I think there's probably pretty good, if I was to guess, looking at the news or at TikTok, there's probably pretty good bipartisan support for something like this. The government and tech leaders seem to be at odds at what's best for technology versus what's best for U.S. National interest. Security interests.
Well, and what it identifies 20 what are called artificial intelligence authorized countries, and they're the ones that can get hardware that can run frontier models. They're the ones that will be able to develop AI, because the concern is, even if we keep our models away from them, the bad actors, they can still build their own. But what if we take that power away too? And so there's only 20 countries that are on that authorized list, and everyone else has very sharply reduced access to any powerful GPUs using this export rule.
And this is coming out of the Department of Commerce, correct? Because they're the import-export folks that are in those organizations.
It is a very complicated. There's a lot of agencies involved in it.
Mm-hmm.
It obviously would have to be Commerce, but there's also the Department of Homeland Security, which is sponsor of it, and things like that.
So this will
this is something to watch, even from change from administration to administration. the folks in Congress are not the friends of technologists right now.
Yeah, right.
Well, it depends.
So anyway,
It's
a fast developing story, and one everyone should be watching to the tech business.
So coming off of the current administration area, which I'm going to try to stay away from that and everything that's going on. We did have, in my world, the data infrastructure world, there's this company, and a lot of people don't know who they are, but DDN, Data Direct Networks folks, they've been privately held. They by Alex and Paul. Very, very, Alex is a very flamboyant Frenchman. I believe he's French. And they've been very darlings in the HPC market. They have traditionally only focused on HPC market or the R&D market. And with AI coming on board, they have just taken off like crazy. And I know from talking to some folks that all they've been doing is pouring money into just ship boxes, which means that's all the inventory and everything else that you're moving. So they've just taken a $300 million investment from Blackstone, which is a private equity, actually publicly traded company, if you want to go look at them. But that brings our valuation to $5 billion, which I think seems like that would be a little low when you think about comparison to some of the other guys that have gone up. But we'll see. I mean, I'm sure what's happening here is that the co-owners are holding their ownership and their power of the company, because it's just been these two guys that have owned it, and it's extremely profitable, et cetera. So it's very exciting to see another hardware vendor and software vendor that has taken on some big dollars into this market. So it's not just about software anymore. It's definitely
hardware is back big time, and of course, but that's a capital intensive game, and you need to be very well funded for the long term to even play these days.
Yeah. And they've been very, very close with NVIDIA all along, because this has been their market. I mean, this is all they've done. Yes, they bought a company called Tintry, means 5-6 years ago, looked like they were starting to try to expand into some traditional data center space. But with AI taking off, there's really no need for them to do that in terms of their valuation or who the company is. They just exploded on that side. So it's been very, very cool, and a big congratulations to these guys out there. So,
yes,
yeah, and that kind of goes along with. And I guess the other thing we were going to do, we were going to take this session and really kind of go through our predictions for 2025. But with all the things that were going on, we said we didn't have time. So what we're going to do is split it over the next few weeks for each of us to take a section and talk about it. So I had mine ready to go, which is, of course, my first two issues they're more granular in terms of predictions, because there's, yes, the market's going to grow. Yes, data is going to grow. Yes, all these things are going to happen. But it's kind of like, what are the specific things that we're going to start to see that probably weren't part of on our venue in the past? And when I sat down and looked at that, I said, one of the biggest things I think is going to happen is the rise of scale-out file, and they're understanding what we need, the need for parallel file systems and the requirements for AI. And to this time, it's always been a secondary market. It's been a market for R&D. It's been a market for the big labs, et cetera. That's who was, because these were so difficult. Parallel file systems are not the easiest things to manage to. You had, the ones that I'm thinking about would be Lustre, would be GPFS or IBM Scale, would be BGFS. Some of the guys are out there, and, it's just not something that somebody wants to go play on. But as we're seeing, each and every one of the vendors are bringing out something to say parallel, scale out, and not just scale out, but parallel file systems. Dell is working on something. You're hearing VAST kind of move in some of those areas. So they have those relationships. Some of them have those relationships with those systems already. But we're also seeing, like, Hammerspace is being put on top of some of these file systems in order to bring a parallel-like activity that's out there. And basically what that means is that the enterprise that's never paid attention to this guy, unless you were a big R&D facility, is all of a sudden saying, I can't get my very high-speed file system, such as PowerScale from Dell or NetApp to perform at the level I've got to make it perform at for AI.
Mm-hmm.
What else is
those file
What-
systems are not designed for that? I mean, we're dealing in entirely new levels of petabytes of trading data and things like that. It's crazy.
So this next year, I think that conversation is going to rise up. I think the enterprise is going to start saying, okay, so what is this? Tell me more about it. What is the difference between A and B? Why can't I do this with this? So that, to me, is the big rise of that. The second piece of that is the understanding and the tuning in of where objects and file belong in that data pipeline for the AI initiative, where that's going. So we've got the data lake that needs to exist. How is that going to exist in the data center? What's that going to look like? How am I going to afford that? Because we're hearing from the enterprise folks that there's a huge sticker shock in terms of what this is going to look like potentially. So we've got to look at different ways for storing that, because if this side is too expensive, I can't justify the ROI here, but can I not justify the ROI here? So somewhere along the line, there is invention and opportunity in here to understand what's going to have to happen from these big object file data lakes.
I think there's a whole ROI problem in general. I'm looking at all the venture capital firms are putting the graphs together of the expenditure on AI and the expected profits over the next 10 years, and they don't add up. You have to do it, but you have to invest in AI, or you're out of the game altogether. But even $80 billion Microsoft is spending on infrastructure, which is going to involve all those things you're talking about, massive file systems of even greater amounts of trading data and all of these things. Where's the end game? Are we going to see exponential growth in profits taken from all these investments? We don't see that. I'm not sure. It seems like the industry's not heading in a sustainable direction. So it's interesting.
Yeah, I think in my experience with file systems in the enterprise, it is very, very, very difficult to get enterprises to change file systems. When you're talking about where they're stored, changing user habits. And in this case, we're probably talking about data scientists. We're probably talking about researchers in the enterprise. And it's and people who are looking to get the data into AI systems. The challenge is that the data, exists on filers and NAS systems, and it's distributed. It's in the public cloud, and trying to get without interrupting users' workflows, getting this data into distributed into some type of parallel file system that's usable and that can use RAG, et cetera, et cetera. I think that will be the challenge of 2025. The need for performance we'll obviously see, but smart folks coming up with solutions that make this as seamless as a transition as possible is the challenge.
And then throw in two of the technologies that are part of this entire AI capability. One is streaming data. If I'm going to do real-time AI with streaming data, et cetera, all of a sudden it brings more complexity to what we're doing into the pipeline. And, we hear the different folks about how do I adopt a streaming data that's coming in for those decisions. And the second piece of it, which is already part of the environment, is the vector databases. And as I take, as the vector databases get indexed, they grow significantly. And so how do I deal with that? So there's probably invention to be had in those areas from an engineering standpoint as we move forward these next few years in addressing, as you were saying, the ROI, et cetera. The last two that I had on my list is that from the enterprise standpoint, we're going to see continuing decrease of any hard drives there and moving to QLC. That's been driving revenue for these guys and is going to continue to drive revenue for the major vendors as they roll out. So we'll see less and less of those blended boxes that are in there as they come of age, and that will fuel the revenue in those spaces. And the fourth area that I'll bring up is the area of data protection and cybersecurity. That does not leave. Dion, as you well pointed out in your CIO Insights, it is still number one on the list. And We will still continue to look at what do we need to change for data protection in order to improve the recoverability and the speed of recoverability. So there's two pieces there. It's not just making sure that we're safe, but now what they're looking at is how fast can I restore and when I get hit. And then the other piece of that is how do I protect not only the secondary data, but the primary data that's been going on. So we'll see the increase of technology, and that will become a competitive advantage for those vendors that have built into their primary storage those capabilities to protect those devices.
Yeah, and in combining kind of two ideas that you are looking forward to, how do you do this with AI? With AI and streaming data, and now when this secondary data now becomes production data, and the need to protect that from ransomware, from cyber threats in real time, and be able to recover in real time. I think we're going to see, again, your premise that, we're going to see the reduction of hard drives. We're going to need much better IO, so much better and denser IO. So 27 terabytes. I don't know if I'd ever say this. A 27 terabyte hard drive just is not enough. It's not enough, and it's too slow compared to the 122 terabytes we're seeing out of the major vendors. There's talk of being SSDs, and going to 256 terabytes of SSDs this year, and the need to just have faster and bigger IO. It's an amazing set of challenges going into the new year.
The way GPUs are so they can take so much data is how do you get the networks and the hard drives to deliver information and as fast as they can process it? That's the core problem right there. Is you basically have to match the data throughput of the GPUs across the entire data center. That's amazing, and they're going to try to do it.
Yeah, and obviously we're going to see opportunities for folks like Cisco. The Tech Field Day folks will be at Cisco Live EU, and I think that's next month or when we're recording this. And obviously HPE, with its acquisition of Juniper and the ability to have these tightly integrated stacks, Dell has its network stack and this ability to build these NVIDIA blessed stacks, which NVIDIA has competitive networking. So just as you start to tear this apart and we start talking about vendor relationships, the ecosystem, it makes for a really interesting year of, how do we get these engineered systems that we want from our favorite vendors that are blessed by the people who are controlling AI, which is basically NVIDIA.
And then the U.S., our U.S. manufacturer, all of our U.S. customers should consider themselves blessed because they won't fall underneath these export control issues. So if we're going to tie all of these pieces together, they'll have the freedom to acquire whatever they want to acquire and be able to build on the systems. So, wow. Well, that brings us almost to the end of the hour. Any other final comments coming out of any kind of cool stuff you guys got? And we'll wrap up here.
No, I just want to give a head tip to our fans at Kamawaza. They've been hard fighting. Luke and Matt have been hard plugging, working with our folks in the Signal 65 lab, doing some really interesting AI. They received $11 million in funding from some Seattle-based venture capitalists. This will enable them to continue what the venture capitalist is calling the Docker of AI. So stay tuned from some insights from our Signal 65 labs, from some of the work we've used Kamawaza to help us produce some really interesting research.
So did you say they're located in my backyard?
They're located in your backyard. I think Luke's home overlooks the sisters. So he is I saw it as he was rehabbing, and he worked for a different database enterprise data company. So yeah.
Okay. Well, I will have to look him up then. Very cool. All righty, guys. Thank you very much for tuning in. Don't forget to like, share, all those good things that we ask you to do as we continue to bring you Infrastructure Matters. And probably the most interesting podcast that you will listen to all week long. All right. Have a great week.